All right, last one. Now let's start talking about which ones we're going to use. Discs, washers, or shells, depending upon the question. So what we have off on the left here is all of our stuff with respect to x, like keeping everything in terms of x's. So when you're in terms of x's, with the disc and washer method, you're going to go about the x-axis. Now I'm going to actually jump and say if you have everything in terms of x's, actually didn't jump at all, that means for the shell method, we must be going about the y-axis. So just keeping that in mind, knowing. Now if we're going to go about, we want to keep everything in terms of y or change everything into terms of y, that means discs and washers need to go about the y-axis. And shells, we'd be going around the x-axis. So shells are backwards. Discs and washers are what you think. Just leave it alone. So let's see a problem. Let's jump into it. So volumes by which method? So we have the region R is bounded by the graphs of that parabola that's upside down, f of x, which is equal to 2x minus x squared, and g of x, which is equal to x on the interval from 0 to 1. We want to use the washer method and the shell method to find the volume of the solid formed when R is revolved about the x-axis. Okay. We got this thing. We can do it. We can do it. I know we can. Let's go. So, what do we got? Let's use the washer method first. So that's saying we're going about what axis? About the x-axis. So washer method, disc and washer method, x-axis, we want to keep everything in terms of x's. Cool. So let's just sketch a little picture. We have a parabola facing down. It would actually look just like this. Well, not just like that, but we're only going to go to 1, which is the right here. And when you plug in 1, that's 2 minus 1, which is equal to 1. And then g of x is equal to x. That's just a straight line. And they're going to connect right there at 1. But it tells you we're going from 0 to 1. Shut up, kitty. I said shut up, kitty. All right. So there's our region that we are going to take. And we're going to revolve about the x-axis. Now it creates this little, there's our little delta x, telling us what we're going to go, we care about our x values here when we do our bounds. Beautiful. Let's set it up. So we're going to say our volume is equal to pi times the integral from a to b of our outer function squared, that radius, minus our inner function squared, that radius, dx. So for this one, it's not too bad. Our outer is the top, and then our inner is the bottom. And it's set up beautifully. It already tells you the f and the g. It's already in there. So we're like, all right, cool. The volume is from 0 to 1. That's our bounds of integration, going this way. And we're going to square up our f of x, which is 2x minus x squared. And then we have to square up our g of x, which is just x, all squared. All right, and let's go. I'm going to jump a lot of steps here. There's no need to. Once this all gets expanded out, we're going to end up with, I think it's what, x to the 4th minus 4x cubed, and then that with that minus it, that's going to become positive 3x squared dx. Once it's all cleaned up, take an integral, do your thing, and we find out that our answer is pi over 5. All right, cool. Cool. Let's go. So now what do we do? For the next one, it asks us to now use the shell method. Shut up, kitty. So now, since we're going about the x-axis, oh no, that means x-axis with shells, that's right in here. That means everything needs to be in terms of y. So we need those different shell heights So that means we have to go through and we have to change everything. And oh no, that means we need to take our f of x. Shut up, kitty. And we have to change this all into y's. All right, go ahead. Shut up, kitty. X equals what? Go for it. Come on. Let's go. Well, you can't do this? You're struggling? Yeah, shell method. That's a terrible idea. It's awful. Is anybody sitting here going like, oh, clearly subtract over the y? Let's write it as negative x squared plus 2x. And then let's subtract out our y. And now we need to use the quadratic formula to solve for x. X is equal to negative b plus or minus the square root of b squared, that's 4, minus 4 times a times, and our c is y, all over 2a. Oh, this is great. You're loving this, aren't you? So we get negative 2 over negative 2. Sorry, I like to write it this way. And then we're going to have the 4 minus 4y all over negative 2. So we're going to get x is equal to 1 plus or minus, and then let's factor out that 4, the square root of 4, times the square root of 1 minus y, all over negative 2. Well, clearly the square root of 4 and 2 are the same thing. So we're going to end up with 1 plus or minus the square root of 1 minus y. Well, which one do we use? Well, the only one we're allowed to use is the 1 minus for it to be on top of the curve. Not 1 plus. We need it to be 1 minus. So, oh, there it is. Great news, huh? We did it. We found a function of y, so we can, let's call this p of y is equal to 1 minus the square root of 1 minus y. Clearly, right? You were thinking that. You're like, why are you showing all this? This is simple algebra. Of course not. And then we can say our q of y. Well, that's not that big of a deal. Well, y equals x. Just change it and be like this. All right, cool. Beautiful. Yeah, so now we can set up our problem. Oh my goodness. So the volume is equal to 2 pi times the integral from, what do they call it, c to d of our radius, y, times, what's our outer and inner function now? What's our outer and inner? Because we no longer have our delta x, we now have a delta y, because we're going to do our bounds going this way about the y-axis, or with about y values, sorry, not the y-axis. So our outer function now is our q of y, or just y, right? Minus our 1 minus the square root of 1 minus y. All of this, of course, dy. Man, that sucks. That was pretty freaking terrible, huh? And then beyond that, oh, and our bounds of integration, that's from 0 to 1. Our y values, 0 to 1, because they have the same x and y values, right? So the integral from 0 to 1, and what is this? Y squared minus y plus y times the square root of 1 minus y dy. Jeez. You're going to have to do a frickin' U sub in there as well, just to solve this thing. Oh my goodness, I don't like this direction at all. But I'll just tell you that it's still going to end up being pi over 5. Math isn't broken. It's still the same volume, just two different ways of doing it. So hopefully we start to see which method that we're supposed to use. They're not really supposed to. Just think efficiency, think laziness, think how can I, as easily as possible, go through and solve this. I think by using a washer method is much better. I mean, just look at how little we had to write. I mean, look at all the frickin' algebra. The algebra just to solve that stuff was more than the entire problem by using the shell method. So, I don't know, efficiency, y'all. So this section, this is it. Good luck, have fun, enjoy yourself, and we'll be back for lengths of curves, talking about arc lengths. And we'll do some, after arc length, we get surface area, and then we'll be done with our applications in chapter 6, and then I think we can probably start getting ready for a test or something like that. So, all right, see you.